as the class is for the most part here, let's go ahead and get started. I'm going to get started here. All right, so what we'll do today is a continuation of what we did on Monday, because we talked about lists, remember? I looked at all the blocks that relate to lists. So what we'll do today is to make use of those blocks. Okay, so I'm going to give you guys some demonstration of how to make use of lists. Lists are really useful, even though it is somewhat of an advanced topic in programming. It is still very useful. It's almost the same thing as an array. If you have taken a programming class, like in C++ or Pascal or Visual Basic, but it is a little bit more than that. Okay, because with an array, you cannot say this element of an array is a number, the next one is another array, and then another element is a number again, and then the next one is text. Okay, like an address. With lists, there's no restriction of what can be an element in a list. Okay, so we'll go ahead and continue that particular discussion today, and also at the same time, I will illustrate how to make use of lists using actual blocks in App Inventor. So this is going to be hopefully a useful class for those of you who want to make use of lists in your projects. So we'll go to App Inventor and get started here. And most likely than not, I'm going to use a whole bunch of test programs. That, and the second time I do it, it would not have a problem. It's only with the first time. So let's go ahead and go to list test 1 again. See, not a problem. Okay. So last time we took a look at the blocks. So what we'll do today is to kind of go through those blocks and figure out what we can do with those blocks. Okay, that's what we're going to do today. So before we go that far, okay, I need to start up the virtual machine because we need to test the programs using the virtual machine. So let me go to start up the Android Studio bin studio.sh and double check that it is actually recording. Yep. Okay. Start up AVD Manager and then start up the actual device itself. Like so. And then we can just I can go ahead and talk about the topics. Okay. So the first thing we want to do is to say, okay, so what can we possibly do with a list? Okay. And we can make this program kind of general. In other words, we can continue to build a list from smaller elements. We can also do it in a different way. So I'm just thinking about what to do with to make this list. Okay. So the first thing is if I want to make a program that's really general, so that you can create any list you want to. One thing we might need to do is a text box. So because that's the most basic thing to include in a list. The most basic element of a list is either a number or text. Okay. So either a numerical value or something that is representing a name, an address, a street name, and so on. So we'll start with that. We'll start with the text box here. And we'll probably have to maintain 2 different lists so that we can combine the list, we can search for an item in the list, and so on and so forth. So we'll go ahead and have 2 lists, which in each one is going to use a label. I'm going to use a label to represent each list here. And then we'll start to use buttons to represent operations. Okay, what are we doing with this list? So we'll have buttons to trigger these operations. And I'm going to arrange it in a different way here. I'm going to use a table arrangement just so that I can contain more tables within a limited amount of space. So the table is going to be, let's make it 3 by 3. That will give us 9 possible items. And then we'll start to drag items into here. So the text box, I'm going to rename it. Okay, let's rename the text box. And this is the only way I can input something, like a number or text. And then these two labels are representing the content of the two lists that this particular program is going to maintain. So I'm going to call the first one list 1, or label list 1, which is reflecting the content of list 1. The second one is going to be list 2, so label list 2. And then we'll start to have buttons here to do something about these lists. So we'll start with creating empty items, okay, empty lists. So we go to user interface, and then we drag 2 buttons into here. And then we'll name the first one empty list 1, and then the second one is empty list 2. And then the initial content, it really doesn't matter, okay? All right. So the effect of clicking the first button, I better change the text on the button itself to reflect what it does. Okay. So empty list 1. Oh, that's list 2 actually. And then here's empty list 1. There we go. All right. So now we can move into the blocks to actually do something and make these lists empty, and also reflect the content of the list using the label. So we go to blocks, and then we say, okay, let's handle the click event of empty list 1. And all I'm going to do, we will need 2 global variables as well, because L1 and L2, list 1 and list 2, are global variables. They have to be global variables because they have to be shared amongst the event handlers. Anything that you want to share amongst event handlers of the same screen, they need to be global variables. Local variables can only work within the scope that they're defined in. So if you need to go outside of the scope, you will need global variables. Okay. So we'll initialize this one to an empty list, okay, which is kind of redundant. We don't need to do this. And then we'll duplicate this for list 2. So here's L2, which is also initialized to an empty list. But we'll have a way to reinitialize each item to an empty list. So over here, we have set L1 to an empty list. And we also want to display it. Now, to display a list, the quickest and easiest way is to set the text property of a label to the list itself. It will do the conversion automatically. So we want to set the text of label list 1 to global L1. So we just say get it and set it like this. Okay. Well, before we go any further, let's check whether this works or not. Okay, so we want to double check and see if when we click the button empty L1, whether it will reinitialize L1 to an empty set and then display an empty set in label 1. In the label reflecting list 1. What does an empty list look like? Open paren, close paren. Okay. So I'm not going too far, just have the program do this part here. And while it is doing this, I will navigate to the command line that I need to run ADB. So Android SDK, go to Platform Tools. Question? Okay, I was seeing things because the rubber ducky looked like somebody's hands up.
Is this from a professor?
My peripheral vision. Yeah, it's somebody really wants a hood ornament on their car, I guess.
It's a Viking, right?
Business communication professor. She said that it's hers.
Oh, okay. Heidi?
Yeah.
Yeah. It looks like a Heidi thing. There's another one over there.
Explain the whole concept to us.
And it also has diversity. This one is a Viking. I think that one has a Mexican hat on it, right?
Look like a cloud or whatever.
No, it's a clown. It's a jester.
The corner over there.
And what does that one have?
It's green.
It's green. Okay. Well, once again, diversity. But the only duck that the only good duck is a roast duck. Roast duck. A little too early for roast duck, but any time is good for roast duck. adb install -r, and it's in my downloads folder called test lists. Why not? Where is it? Oh boy, where did I put it?
List test.
Oh, list test. There we go. Thank you. And then we run it in the emulator. This test right there. Okay, so we click empty L1 and it is now initialized to nothing. Great. Okay, not a problem. So we can now switch back to the code here.
Is that a 0?
Huh?
Is that a 0 or?
No, it's open and close paren.
Okay.
Yep. So we'll go ahead and duplicate this block so that we can handle empty L2. Pretty much do the same thing except for list 2. I want to maintain 2 lists so that we can do certain operations that require 2 lists. Okay?
Label.
Hmm?
The label.
Oh, the label needs to change too. Yep. Label list 2. There we go. Okay. So now we have 2 of these things. I'm not gonna bother to test the other one. And what we'll do next is to say, okay, creating empty lists is not very exciting. So we want to be able to add something to a list. And I want to start with something that's simple, just adding text. Okay, whatever the text box has, add that to a list. Okay, append it to the end of the list. Or better yet, we'll go ahead and be able to control where we want to insert into a list. Okay, but to do that, I need to go back to the designer and have a different box. So when I have multiple boxes, I probably should start to label these boxes. And to label boxes, the best way to do it is to use a table arrangement. Okay, and 2 by 2 is fine. I'm going to move this one over here, and then I use a label to reflect what it is. Okay. So here's a label, and I want to say this is the content, and then the other one is going to reflect the position. So I'll make another text box over here, which is only controlling the position of something. So let's go to label again. And this one is about position. But I also want to change the name of text box 1 into text box position. So this way, when I look at the text boxes, I can see what it is for. Position. There we go. Okay. So the next thing we want to do is to be able to insert the content into a particular position in label 1, in list 1. Okay. So let's go ahead and do that. Switch to the blocks, and this time I'm handling. Oh, I need one more button for that, right? So I will drag and create one more button, and for this button, the job is to insert into L1, into list 1, and I will change the name of the button itself to reflect that. Okay. Insert to insert L1. That should be fine. There we go. So now we go back to the blocks and say, okay, let's see what happens when we click it. So we go to L1, selected the click event handler, and I'm not going to do any error checking. In other words, this time I can potentially end up with a bad runtime error because I specified like the wrong position. Okay, but I want to test it. I want to see what happens. So what I want to do here is to go to the list operations, things that I can do with lists, and say, okay, let's go ahead and do the insert. Okay, insert is right over here, and in order to use the insert block, I need to specify 3 things. First, I need to specify which list is getting affected by this operation, which is the first slot. The next thing is where do I want to insert in that list, which is the index, And then the last one is, what am I inserting into this list, which is the third thing called item. Okay, so we'll go ahead and see what we can do here. The list is just L1, so I can just pull this one here. The index is what is specified by the second text box, so I go to the second text box or text box position and say, give me your text, and I'll use it as a number. Okay. And then the third one is, what am I inserting into it? That would be whatever is in text box input 1, text box input, so the text of that becomes the item that I'm inserting into L1. Are we doing okay so far with this code? And then all we need to do is to replicate this block here, just so that we can look at the current content of L1. Now you can probably see that everything is going to end up with the refresh of the two labels. So if you don't want to have to do this, okay, is to set up a timer. So every 200 milliseconds, it updates itself. So then you only have one place to say, okay, let's go ahead and use the current content of L1 and make the text of label list 1 to be that particular list. And you don't have to insert this code every week. Which may or may not be a good approach, because if it's doing it in the background, even when you don't want to do something like that, it's clicking, it's happening automatically. Yep.
I don't quite understand the index.
The index?
Yeah.
The index specifies where you are going to put the new item.
I understand that part, but I don't understand why you have the text.
Because I am using the content of the text box as the index to specify where I want to put it. Is that okay? And we also want to just double check one more time and see how this block is used. So we look up insert list item, and it says insert an item into a list at the specified position. So if you specify index to be 1, then whatever you insert in the item becomes the first item. Okay? If you specify the length of a list, then the item becomes the last item. Okay. All right. So let's go ahead and see, how this works. So once again, there's one really kind of interesting question, because what do you do with the first item, and how do you add something to the beginning of a list, and how do you add something to the end of a list? Okay, so those two would be interesting questions that we can probably answer by testing it. It's compiling. I'm just waiting for it to finish the job. So as you can probably imagine, we're going to create more and more complex lists. So at some point, I'm not going to recreate the list from scratch anymore, but it's still simple enough that we can do it at this point. All right. So now you can see the interface is slightly different. We have insert into L1 as another button. So what we will do is to say, let's go ahead and insert the content of, let's say, my name, T-A-K, as the first item of L1. Okay, so I'm going to press insert into L1 here, and you can see that tag becomes the first item. Now, I want to see what do I need to do to insert my last name into the list as the last item. Okay, so it's A-U-Y-E-U-N-G. Okay. What do you think should be the position of my last name? Should it be 2 or should it be 1? It should be 2, because if I use 1 again, then all becomes the first item, and it will shift tag to become the second item. If I want new thing to become the second item, I have to specify 2, because that's the position where it is going to belong to. Nope. Oh, I forgot to change the 2. Okay, fine. Fine, we'll add something to the end of this. Okay, we'll say Dr. Tech. D-R-T-A-K. And we want it to be the last item. Okay, so this time we have to specify a 3. Okay, let's try that. And it becomes the third one. So it is the length of the list plus 1 if you want to append it to the end, not just the length of the list. Is that okay? Because right now the length of the list is 3. If I specify 3 again, then it will be using, it will put the new item as the third item, but what is already the third item will become the fourth item. Question?
That's different than C and Java, right?
Yeah.
When we go to C and Java, we gotta convert back to starting at 0.
Yep. So we'll try this one more time. You know, if I want to insert something at the very beginning, we'll test whether we specify a 1 or specify a 0 as the first item. Okay. And so we'll go ahead and change this to professor, prof, P-R-O-F. So prof. And the position, I'll try 1 again. And click insert into, and prof becomes the first item. So the next question is, okay, let's say we specify something else here. Bad professor. Okay, there we go, bad. Okay. And then we specify a 0 this time. Okay, in other words, I'm giving it something that is not reasonable. Okay, and then see what happens. Bing, gives you a runtime error. Now, when you get a runtime error like this, it doesn't give you a chance to continue either. It simply says, you try to insert something or the list index is smaller than 1, and your only option is to end the application. You're crashing the application, then there's no way to recover. So what does it tell? What is that telling you? It tells you that if this is an actual application, then you better double check. Okay, so that you don't generate a runtime error. It is much better if you use your own dialog box to tell the user, hey, this number is not right, and then give the user a chance to do it again, okay, rather than crashing out of the application. So let's go ahead and see how we can make this application more robust. There are several things that I can do to make it more robust. The first thing I can do is to make sure position is a number. And I am going to do this in a way so that it cannot be anything other than a number. So we can just go scroll down here and say, and click numbers only. So this way they cannot even enter text in the text box for position. That's one way. But they can still specify the wrong value. They can specify a negative number. They can specify 0. They can specify a number that is longer than the list itself plus 1. Okay, so I need to do all kinds of checks like that as well.
What happens if they specify longer than the list? Does it give
I believe it will give you the same kind of error.
Okay.
And it's real, real number, not an integer.
Well, let's try that.
It won't pad the list with zeros or anything.
It doesn't pad. So let's give it a try here. So we'll specify 3 here because the list is empty to begin with. So this position does not exist in this list. So we click that, and it says list index too large. But the good thing is it at least tells you that we are trying to insert into item 3 of an empty list. So the error message itself, even though there's no way to recover, it is still telling you something that is semi-useful. I would call this semi-useful because if you have multiple insert blocks within your App Inventor program, then it doesn't tell you which one is causing this problem. So then you have to go into your application and look into each and every single one and say, okay, was it this one, or was it this one, or was it this one that is giving me this problem here? Now, since this is responding to the click event of a particular button, it really helps me to narrow down to which one pretty quickly. But if you have this operation inside a procedure, then it becomes a lot harder to find out, okay, but who's calling the procedure to begin with. Okay. All right, so now that we have this thing here, let's go ahead and switch back to the blocks and see how we can do a whole bunch of stuff to make this more robust. And we go back to the designer because now I know I need to use a notifier to basically let the end user know that there's a problem and what the problem is going to be. Alright, so going back to blocks here, it means this stuff is working, it is okay, but I need to do some error checking. The first thing I need to check is whether the position is within the correct range or not, okay, or whether it's a number, okay. I don't need to check whether it is a number or not because of the restriction on the text box itself. Okay, so that part I don't really need to check. Yep.
Without having a decimal point.
That's a good question. Let's try that. I think it will give you the same error that the number cannot be used as an index.
Okay.
Okay, so 1 is okay. We know that 1 works, right? So we'll make this 1.1. Oops. Long press. There we go. Insert, and it says attempt to insert item 1.1 into the list. The maximum valid item number is 1. Okay, but that's not really a good error message. Okay, let me tell you why that is not a good error message. So we can insert R into the first position, and we'll do it twice. So we say insert, insert. Okay, so we have 2 R's in the list right now. So I should be able to specify 1.5, right? Because I should be able to specify 1. I should be able to specify 2 as the position to insert something. So it cannot say that 1.5 is too large or too small anymore. So what is it going to do? Is it going to round it down? Is it going to round it up? Or is it going to complain and say this is not an integer? Well, we'll test it because the specification does not say anything. Well, but since I'm using R, I cannot tell, so I will just say R-S-T-U. Okay, fine. Now we can tell. Okay, so we say insert into L1, and it is equivalent to it's equivalent to a 2. So it's rounding it up. It's using the rule of 1.5 or more is rounded up to a 2, and then if it's less than 1.5, it is rounded down to a 1. So it's doing rounding, which is not necessarily the thing that I wanted to do, right? Okay, so we want to test all of these things and do error checking. How do I do that? Well, a whole bunch of conditional statements, right? But do you think that's going to be unique to this event handler? That may not be unique to this event handler, right? So what we want to do is to make it kind of somewhat universal. Okay. So to make it universal, we are going to define a procedure. A procedure is a chunk of code that that you can invoke from any place. So we'll define a procedure here, and we'll say is index valid. Okay. That's all it's going to do. And we'll end up with 2 types of index valid. So we'll say valid for insert in this case, because for insertion, there's one particular case that is not usually true, but it's okay for inserting. Now you can see that the result has a slot like this, not a usual tab like that. What does that mean? It needs a value. It needs a value, right? Well, we can specify a value here, a single value, or we can use a conditional statement to specify the value. I think it is easier to use a conditional statement to specify the value because it can separate the cases, so it's easier to deal with it. So we go to control here, and then we look at things. Would this fit that particular slot? Nope, 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 nope. Yes, yes, and also yes over here, yes over here. These do not really matter, but I want to do this one here. Okay, so this one. Okay, so when you look at this one, it turns one single value slot, which is this one, this thing over here, into 2 different slots. One slot allows you to perform some operations, and then after the operation, it allows you to specify a result after the operation, which is the most general way of performing this kind of operation, is to do something first and then you tell the block what is the correct result. Is that okay? All right. And then the other way to do this, which is also general, is to use a local variable. Okay, so you can see that when you use a local variable, there are two ways to make use of local variables. One way to make use of a local variable is to define a block that has a particular value as the result. Now this gives you the extra advantage of being able to utilize a local variable for calculations within the event handler, which is something that I want to do. Is that okay? So the typical way that I do things with a function or a procedure that returns a value is I will specify the result, okay? And for purposes of this particular program, I can assume the result to be false, okay? So I'm looking for reasons to say that yes, it is valid. But otherwise, by default, it is not valid. Is that okay? Okay, first thing is I want to see if it is a integer. Okay, so how do I test whether a number is integer or not? Okay. Let's go back here, specify that block because I want to perform some operations first, and then I want to indicate what the result is. How do I check for integers? Because I want integers between a certain range. Well, the first thing we do, okay, whenever we have a question like that, is to go to the math block and just take a quick glance through it and see what can be helpful here. Not helpful, not, nope, nope, nope. Potentially, nope, 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 nope. Potentially. These minimum, not so much, but one of these functions may be helpful. So we have ceiling, we have floor, those can be useful. Rounding is done automatically. Sine, cosine, convert, is number, but is number is not going to be helpful because 1.5 is a number, but it's not an integer. There's nothing here that says is integer, right? But I want to see if it's an integer. Okay, so it sounds like we need something to check whether a particular value is an integer or not.
What were those little arrows on the sides of them down there? Like is number, can you drop down that little arrow there? What is that?
Ah. It allows you to check all of these things. So it allows you to check whether it is a number or not. You can ask whether it's a base 10 number, whether it's a hexadecimal number or a binary number. So none of that is really helpful because 1.5 is a base 10 number. Is that okay? But it is interesting. Okay, that was a good question. I did not know that you can check the base of a number. But in this case, it is not particularly helpful to me. So I have to kind of toss it away. Okay, the other ones sounds like some of these can be useful. So we'll take a look at the ceiling. Okay. And it has square root, absolute, negative, or negation, log, e to the power of round, ceiling, and floor. None of these is directly useful, but they are almost useful. Okay, so I'm going to pick the floor, and I'm going to use this as a component to see whether the number is an integer or not. So how do I use the floor function? Okay, what is the floor function of something?
Integer below the number.
It is the largest integer that is less than or equal to whatever you want to find the floor of. Okay? Let me say that one more time. The floor of x, whatever x is the largest integer that is less than or equal to x. Okay. Document camera or whiteboard? Whiteboard? Document camera? Okay. 26 bucks from eBay. Even I can afford that. It's like how many Starbucks?
That's 6 Starbucks.
5, 6? Okay. But your Starbucks can be different from mine because I only get iced coffee, which is only about, yeah, it's a lot more, 10. I think it's $2.50, $2.50 for a iced coffee. And the Starbucks people like me too because everybody wants like the whole thing. They have very specific requirements, and I just go like iced coffee, anything in it? Nothing, just iced coffee. They like me. They say, "Oh, you are an easy customer." And I don't have to worry about calorie and all the other stuff too. It's just iced coffee. Well, I actually lied because I don't really go to Starbucks for the most part. I have my own coffee grinder and coffee maker at home. So I figure it's about 30 cents if I buy 30 cents per coffee mug per mug of coffee. If I buy the little packets, the Cool Rack packets from Costco, it's about 30 cents per cup. But since I use a refillable, it's about 10 cents per cup.
This is
So-
how they make money.
Huh?
This is how Starbucks make money.
Oh, lots of money. Not just money, but lots of money. This thing is now equivalent to 260 cups of coffee instead of 10 or 5. All right. So the floor function. The floor of x is the largest integer that is greater than or equal to, less than or equal to x. There we go. Okay, so that's how we define the floor function. How is this going to help us determine whether x is a integer or not? What is special about integers as far as the floor function is concerned?
They equal.
Or should be so.
They should be the same, right? The floor of any integer is the integer itself. All right, so we have a way to differentiate whether a number is an integer or not. Okay, excellent. So we use the control here, and we specify a conditional statement because I assume everything is false. So I'm looking for reasons to say that, yes, it is okay. So I can do this. All right, so now we use math equality. Now remember, there are different types of equality. There's one equality check in text, there's one equality check in logic, and there's one equality check in math. In this very specific case, you have to make sure that you use the math one. Okay? So we use the math equality check between the floor function, or the result of applying the floor function, versus not applying the floor function to that thing, to the item that we are checking. Okay, so what item are we checking? In this case, we're checking the index, or whatever is inside the text box for the index, right? So if I want to, I can just plug in here and say, is the text of the text box responsible for positions? And I don't need anything input, any parameter to the function itself. But what if I want to apply the same logic to some other values? And I can't do anything, right? Okay, let me just show you what I meant by that. Okay, so if I were lazy, okay, and just say that I don't want to do anything to use parameters and stuff like that, seems like a waste of time. So what I can do is to say, let's go to this text box here, grab the text property out of this text box, and just plug it in over here, and then we'll replicate it, and then and also plug it into the other side here. That would have accomplished what I wanted to do right now at this point. But that also locks this function down. This procedure is now only going to work if we want to check whether the text in text box position is an integer or not. If I want to check any other numbers, it's not going to work because it only used the text of the text box position to do the job. I don't want that, okay? Because it limits the application of this procedure to only the text inside of that particular text box. So that's not a very good approach, okay? Not something I want to do. Instead, what I will do is I'm going to add one input to this particular procedure. An input to a procedure is really just something, okay, in this case, it has a default name of x, which all basically means when I call this block here, I have to supply, hey, you want me to check whether a number is valid or not? Which number are we checking? Is that okay? So we'll go ahead and change x to index because it is the index that I'm checking. So I just want to name the parameter accordingly so that we know what we are dealing with. So we want to make sure that the index is the same as its own floor. Okay, there we go. Okay. If it is, it's an integer. And since I am notorious of not remembering why I do certain things in a program, I would add comments so that I can remind myself later on and say, what is this doing? Oh, okay. This is for checking whether index is an integer or not. If so, proceed to check some more. There we go. So with this comment here, then later on, if I look at this code and go like, what was I thinking when I wrote this code? What is this block doing here? I can click on the comment symbol and remind myself, oh, okay, so this is how I check whether a number is an integer or not. Is that okay? So this approach is highly recommended, okay? And I know a lot of us do not like commenting because it seems like a waste of time. And it is a waste of time if you don't need to use the program in the next, once you're done with the program and you don't need to use it again, and you can write the entire program within hours, commenting can be a waste of time, okay? But are you guys all going to be just writing simple programs so you can get done in a few hours? I surely hope not. So you're going to write programs that you probably want to maintain for at least months, if not years, okay? So now the question is, can you come back to a program, the source code of a program, after 3 months of not touching it and be able to understand your own code and say, oh, okay, I know why I have this line of code here. I know why I have this block of code over here.
Sometimes.
I can do it very, very occasionally. Most of the time I look at my own code, especially in Perl, I'm like, whoa, wow. First of all, I was impressed that I could come up with something like that. Then I get depressed because I could not understand myself. It's like, I was pretty smart, with emphasis on the tense. Because I don't feel very smart now. And look at the code like, what was that? I mean, so that's why commenting is really helpful. Okay, in terms of maintenance and long-term projects, you always want to comment as much as you can. Okay, so now that I confirm this is a number and it is an integer, I can now move forward and say, okay, since it is an integer, now I can actually check the range. Oh, the range of what? Well, the range of indexes of a particular list. Which list are we talking about? From the context of what we're dealing with L1 as the list. In other words, if I want to be lazy, I can do something like this. I can say, okay, let's further check that this is, it's at least 1, okay? Because that's what we need. So if I want to be lazy, then I would just go ahead and say, I want index to be at least 1. So once again, we have a comparison. We want index to be greater than or equal to 1. So this part is okay because every index has to be at least 1, so that's okay. Then we're going to duplicate this block again and say, oh, but we also want to check the other end of the indexes. We don't want this to be greater than the length of the list plus 1 because you need that plus 1 to specify the last item. Okay. But which list are we talking about? Well, we know which list we are talking about here from the context of why I'm writing this procedure. So I want index to be less than or equal to, not 1. The 1 is going to be useful too. but I want it to be 1 plus the length of the list that I'm dealing with. Okay, which list? L1, right? So we can now go to math. We need an addition here because we need to specify the plus 1. And then we need to go to lists and say, okay, the length of a list. Which list are we talking about? Well, it's my global variable L1. So we say get L1. And then slap this whole thing over here. And now we have the proper range checking for L1 itself. But once again, this is not a good approach because it makes this entire procedure, it will only work on L1. What if I want to check whether it's a valid index for L2 or some other list that is not even a global variable? Can't use that anymore. Okay? So it is much better if you just say, okay, let's change this. Let's change the procedure again by adding another input. Now, what is called an input in App Inventor is called a parameter in most other programming languages. Okay, so we want to add one more parameter. In addition to index, we want to specify we also want to be able to specify which list we are dealing with. So we just say, okay, this is the list that we're dealing with, and we want to check whether this index is valid for inserting into this list. Okay, so now that we have the list as a parameter, I don't need to refer to the global variable anymore, and instead I can refer to the parameter called list and put it over here. So now this procedure is applicable to just about every list, not just the global variable that we're dealing with. Is that making any sense so far? So now that I have confirmed that it is an integer, it is at least 1, and it is also less than or equal to the list, the length of the list plus 1, so which allows me to append to the end of a list, hey, it's okay now. Okay, if I can get all the way down here, then result should be true. So now we set result to be true. But for everything else, it's going to be false. For everything else, it's going to be invalid. It's not a valid index. Is that okay? So in this case, I'm assuming everything is bad unless I have a specific reason to say it is good.
And that last little result down there, nothing in it it's not going to affect it.
Now we have to specify what we are returning, which is result. Yep.
On your first do loop? Oh. Okay.
Because result is a local variable, but the local variable is defined outside of the do result block. So I can still utilize result as a local variable when I specify the result of that block. Yep.
So the reason we're putting false is because we're assuming that everything's not going to work?
Yeah, because in this particular case, we're looking for a very, very specific chain of conditions to be true in order for the index to be valid. So it's easier to assume it is false to begin with and only look for the very, very specific reason to make it true. Okay. Because otherwise, I will have to use not if then blocks, but if then else blocks, and also assign result to be false for all of the else's. So we can do it that way. It just makes the code a little bit more complicated to read. Yep.
So the do block, the do result block, is a way to kind of shift the
nesting.
I forgot what it's called now. The event handler's do portion inward more. In a sense?
We are invoking a subroutine. We are calling a procedure from inside the event handler. So that means, if I need to check this now, I can now go to here. Okay, so that's a good question. How do we utilize a procedure that is defined like this? So the way to utilize it is to go here, and then we put a conditional statement around this light blue block because this is what we want to protect. Okay, so we use a conditional statement and put this block inside. Okay. And the condition that we want to check is to see whether the index is valid or not, right? So that means we just call the procedure. we say call the procedure that we just defined, which is index valid for insert, and then we now specify which list are we talking about. We are talking about list 1, and which index are we talking about? It's the text of the text box for position. So now we specify, we have that already here, so we can just duplicate it. So that's the reason why we are using it. That's how we use the function. And the reason why we can use it this way is because the way I define is index valid for insert is only going to return true or false. What can you use true false for? Well, we can use it in a conditional statement. Now in this case, in a way it is good, in a way it's bad, because it only tells me whether it is valid or not, but it doesn't tell me why it is not valid. In other words, if I want to use an else here to give the end user an error message, I cannot tell the exactly the reason why it is not okay. I can only say that it's not okay for any one of these reasons, but not a specific reason. Is that making any sense? All right, so now that we have this, let's go ahead and check the program again, because we want to see if it will still give me runtime errors. Now this program is not very user-friendly, because if it's not within the right range, it simply won't do a single thing silently. So it doesn't say that, well, I'm not going to do this because you gave me something that's bad. It just doesn't do it. It's kind of like you guys asking me, hey, can I turn in this homework assignment late? Instead of saying no because I said so in the syllabus, I just do not answer at all, which would be bad. Waiting. Yep, there we go. Took a while. Okay, switch back to this command line. Switch back to the emulator. Test it again. All right, so let's go ahead and give it something unreasonable. We'll start with 0. And it doesn't do a single thing. It didn't crash, right? We'll give it a decimal number. Okay, that's good. Let's give it a negative number. Okay, no problem. But we also want to make sure we did not actually break the code. So after we test the 8, we want to give it a 1, just to make sure that the code is still working. So give it a 1, and it does insert. Okay. So are there any questions about this particular program? No questions? Now this is a kind of a good time to also bring up a particular skill set for app programming, which is kind of something that I'm not going to teach in this class. This is all because when you mentioned user experience as a focus of, is it software engineering? Yeah. So that's an interesting area because when I study computer science, it's all technical stuff. Okay, how do you compute something? How do you work out the logic of doing something? But we didn't really put a whole lot of focus on how to make a program user-friendly or how to make it usable to most other people. Okay, but these days it is becoming increasingly important. So when you look at software engineering user experience, and let's say we are looking for university programs, you can see UX stands for user experience, and you can see that there are ranking already in terms of which school would teach user experience, user design, user interface, human-computer interaction, human-centered computing. They're all basically referring to about the same thing. There might be some minor differences if you ask people in that field, but they're all about, okay, here's a program. How do I make it user-friendly? How do I make it so that people cannot make mistakes easily? And how can I make it so that people can navigate to the proper screen, quickly. And of these accredited online computer science and engineering program, so these three, I'm guessing, is the top tier programs when it comes to user experience, user design, and stuff like that. So the question is, why do you think this is now becoming a focus of universities? And when I was a graduate student, nobody mentioned anything about user design and user experience or anything like that. What had changed from 20-something years ago?
I think the size of what you're viewing is much broader than in the past, right? You used to have a single monitor, maybe 20 inch, 21 inch, whatever. But now we're going all the way from 4 or 5 inches all the way up to 30 some odd inch.
Well, let's go a little bit further back in time, maybe like 30 years ago. So 30 years ago, 86, okay? 1986. How do you hook up to the internet in 1986? It's a trick question, by the way. You don't. Because there ain't no internet back then. Okay? There are modems, okay? People had modems, and they used modems to hook up to what again? BBS. Okay? Bulletin Board Service. So you use a modem to dial up to either somebody's home with a whole bank of modems, or some other entities. But all you can do is to hook up to a local BBS, and then between the BBSs, they have some kind of a network, so they can actually relay messages, through from one BBS to another BBS to another BBS and so on. But it's very limited. What kind of speed are we talking about? Why do you think I don't have to worry about GUI when it comes to online communication back in 1986?
There's nothing graphical to transmit.
Sorry?
There's nothing graphical to transmit. So,
Well, because it doesn't make sense to transmit graphical stuff or GUI of any kind. Because back then, we only have 300 to 1200 BPS communication speed. Okay? We can look it up. Okay? Modem speed in 1986. 30 years ago. Okay, so we can look at the history. So we're looking for the time frame. Okay.
1989 went up to 14.4.
Where you guys can read a lot faster than me.
1986, 9600. Yes.
Where? Oh, right here. Okay. So it introduced the quote-unquote high-speed transfer protocol in 1986, exactly 30 years ago, which operated at 9600 bits per second. Okay. So, and then these days, kids will ask, okay, I don't understand this. How many gigabits per second again? Right? They look at this number and go like, this doesn't look like something that I recognize. It is not, GBPS, right? Gigabits per second. Well, let's figure out how many gigabits per second we're talking about here. Okay, so we'll even round it up a little bit just so that it is easier to calculate. Okay, 1,000 million giga. Right? 1 giga is 1 billion. So we are talking about 0.00001 gigabits per second. Fine.
There you go.
Okay, so at that speed, it is not bad because you can actually, it is faster than most people can read, which is much better. Hey, okay, don't laugh because when your modem is only operating at 300 bits per second or 1200 bits per second, even I can read faster than my modem can transmit or receive. Now, I'm not sure about with compression, but without compression, I can at least keep up with my modem. So, but this is still insanely slow compared to the standard today. So why do you think user experience was not an issue back in those days? Because I want to make you guys think. Okay, why is it important now? Why was it not important back then?
Was it possible back then?
Hmm?
It was impossible back then.
Well, you don't have GUIs back then,
Right.
okay? But even with a text interface, there are still text interfaces that are easier to use and some that are harder to use. But even that was not a big issue. What is the clientele of people who own these modems? People who would spend $400 on this kind of modem. And $400 back in 86 is, 86 is a lot of money. So who would spend money on a modem like that?
Giant nerds.
And $2,000 on a PC, right?
Computer
Engineering
people.
scientists.
Yeah, geeks, nerds, geeks, people who are technical, people who have no problem using any kind of user interface. Because they will figure it out. Okay? Because what is the population, what is the percentage of population that has a personal computer at home? A single personal computer at home back in 86?
Not big.
Just give me a guess. How many household has one single computer?
3%.
Probably in single digits, okay? Single digit percentage, okay? Which means, and out of those people, they're all technical people. These are people who operate mainframes at work, people who are scientists to begin with, people who actually know this stuff, okay? Or they're not easily deterred by bad user interfaces. Okay? So fast forwarding 30 years, okay? 30 years is not that long of a time, okay? Fast forwarding to today, I'm not even going to ask how many households, what is the percentage of household with at least one computer, because that's going to be close to 100%. So the question to ask these days is, how many devices do you have that you bring with you to school? Okay, so you have your cell phone, one. Some people, cell phone and a laptop computer. Most students in computer science have those. Okay, and then some people on top of that have a smartwatch, tablet. So 3-ish, computers per person. Okay. Now let's say you're not dealing with computer science students. Let's walk over to the art department. Okay. Still, okay. Most people have a cell phone. Now, are these people, in the art department, are these people not easily deterred by bad user interfaces, where you have to go through 20 menus to find something?
Easily. Yes.
They'll just give up, right?
Yes.
So that is the reason why UX is important now, because devices are now inexpensive. For one, everybody has one. And two, we have the horsepower to do graphical user interfaces. Okay? That's the reason. And also in a mobile programming class, it is particularly applicable because how many people have bad experiences with programs that are just not user-friendly? Okay? Well, so if they have competition, and the competition has a better user interface, easier to use, more effective, then people will go to the competition. Does that make any sense? And that's why universities now start to offer these programs, because industry is calling for these programs to exist. It's like, we need people who do not just program, but we need people who can design apps, web interfaces and stuff like that that's easy to use. Okay? Yep, go ahead.
Plus, we're not just phones and computers, we're cars,
Yeah.
dishwashers, refrigerators. I mean, the interfaces are blowing up all over the place, right?
What is a Tesla?
It's a car that requires firmware updates.
It's a true mobile device. A Tesla is a mobile device that can drive itself. But it is a mobile device, okay? It just looks like a car. Okay, it's a mobile device that looks like a car, just like your cell phone is a computer that looks like a phone. It is not really a phone, it's a computer, okay? It just looks like a phone. It doesn't even look like a phone anymore. They should be retro and design those little handset thing. and not just make it a Bluetooth thing, but make the actual surface of the handset touchable and have the screen to actually wrap around the shape of a retro phone. So you pull that kind of retro phone handset out of your pocket and you talk on the phone like the good old days. But it is touch sensitive too, with fingerprint authentication and all that good stuff too.
Is the Tesla an extreme example of future feature creep?
If it started off as a phone, then yes. if Elon Musk originally said, I want to design a phone, and he ended up with a car, then yes, it is an extreme case of feature creep. But that's a good one. I like it. All right. Well, but that's why user interface design is now a very important thing. And most people look at this and go like, oh, that's really easy. You just need to position things in a certain way. There's really not much to it. Well, that's not true. Okay, there's a lot of psychology that goes into this. There's a lot of statistics that goes into this. Okay, because people look at how people utilize different types of user interfaces, and they figure out how do people scan on the screen, how many things they can keep track on a single screen, and stuff like that. How people organize information in their mind. How do you organize your menus? Well, we know that we can only focus on 3 to 7 items at a time, but which 5 to 7 items do you want to put on the screen? They cannot be unrelated stuff. They have to be related stuff organized in a certain way. So I personally do not know much about UX, user experience and stuff like that, but it's a field that some of you may want to kind of pursue because it is important, for one thing, and two, they definitely do not have enough people, cranking out of these programs at this point because it's relatively new, and I know industry, is focusing a lot on user experience these days. Is that okay? All right. It really makes sense because I think self-driving cars will become the norm by 2030, if not earlier. Okay. Yep.
Wasn't it Ubuntu's agenda to make Linux more user-friendly?
I think they want to make it, the original idea was to make it a desktop operating system, but yes, they want to move it more from the backroom servers into kind of more of a user oriented operating system. I think there are some phones that can run Ubuntu. There's at least one that can run Ubuntu or Ubuntu's own user interface, not Android. So you can look up Ubuntu cell phone. I think there's at least one phone like that. All right. So getting back to all the boring stuff that we are dealing with here. Well, it is kind of important. Okay. So the next thing we want to do is to say, can we put a list inside another list? In other words, can we use a list as an item of another list? Okay, and how do we do that? Well, as it turns out, it is not really that much more difficult compared to what we have done already. So it's going to be about the same thing as this one here. Okay, so we'll go ahead and make a new button and say we want to insert list L1 as a list into L2. So we'll go ahead and make a new button to do this. And it will say on the label of the button, we want to insert L1 to L2. So this time we're inserting a list into another list, okay? Which is actually building up the program so that we can do key value pair manipulation and stuff like that. Okay. All right. So now that we have this, we will change the name of the button so that it reflects what the button is actually doing. Insert L1 to L2. There we go. And then we switch back to the blocks and see, okay, how do we do this? Well, it's very similar to this one. Okay, so I'm going to duplicate this entire block. I'll put it in the backpack. And then I can throw away the other duplicate. And scroll down to a good place. Retrieve it from the backpack. Change this to the handler of L1 to L2. Insert L1 to L2. And then all we need to do is to change some of these things here. Instead of checking whether the index is valid for inserting into L1, now we're dealing with L2. And then the index position is still the same, okay? And then when we actually do the inserting, we are now inserting into L2. L2 is the one that is getting bigger. The item that we're inserting is no longer the text box, but the entire L1. So we're inserting the entire L1 as an item into L2 at the position that we specify. And also when we need to update, we are no longer updating list 1. We're now updating list 2 because that's the one that is getting affected by this operation. Okay, there we go. I believe that is it. Okay, so let's go ahead and see what this program is going to do. It should not be very surprising. If anything, this is like, okay, we kind of knew this is what's going to happen. Upload the program. There we go. And test it. All right, so I'm going to create L1 first, then we'll insert L1 into L2. So we'll create L1 first, and let's go ahead and create it using my first name as the first position. Insert into L1. And then we'll associate that with a particular number. Okay, so we'll say 30. And we'll make it the second item. So we need this to be at index 2. Insert into L1. Okay, so L1 is now a list of 2 items. And this is a perfect setup as a key value pair. Okay, because we have a list of 2 things. And the first one is called the key. This is how we search for something. And then the second item is the value associated with that key, which in this case is the value of 30. So now we click the second button, the button labeled Insert L1 to L2, and then we'll see what happens. Oh, that doesn't work because 2 is not a valid index. Because L2 is actually empty at this point. See? And so we have to change position to 1 in order for it to be valid. Insert L1 to L2. So you can see that L2 looks almost the same thing as L1, except instead of single pair of parentheses, it has double pair. But that makes sense because L2 is really a list of 1 single item. Just so happens that 1 single item in L2 is a list by itself that has tag 30 as its own components. Is that okay so far? So now we want to do something maybe a little bit interesting, okay? Because what I want to do is to change L1, okay? So we'll go ahead and change L1 in a very minor way. I'm just going to add something to L1. So let's go ahead and add something to L1. We'll just add the word end as the third position of L1. And click that, okay? So now it's tag 30 and then end, okay? And we'll go ahead and add that to L2 again. So we're going to add L1. We'll insert L1 to L2 one more time. Okay, we'll change the position to 1, so we're inserting at the very beginning. So you guys can tell me what do you think is going to happen when I click insert L1 to L2. L1 at this point looks like this. It has 3 items. It is tag 30 end. That is what L1 has at this point. And I'm inserting into position 1 of L2. So L2 already has 1 single list in it, but now I'm inserting another list as the first position. So what do you think should be L2 after I click insert L1 to L2? It will be open paren, tag 30, and close paren, open paren, tag 30, close paren, close paren. Okay? Well, you remember what I said last time? Yep. Yep. That's because when you change L1, so what is really happening is there's only one L1, okay? That we have L1 inside L2. Okay, so let's say this is L2, okay? L2 has an item that is actually L1. So when you change L1, you're changing the L1. There's only one L1. In other words, there's only one list. Okay. I should have put this. L1 is quote unquote, pointing to a list here. Okay. tag 30 original. Okay? So when you say that L2 has a single item, which is L1, what we're doing is we have L2, okay? L2 is pointing to a list where the first thing is pointing to that. Are we doing okay so far? So when we change L1, we're changing, there's only one L1, there's only one list with tag 30 in it instead of two. L1 is pointing directly to that list. L2 has one item in the list pointing to the same thing. So when I added when I added end to the very end of what we call L1, it's actually changing what L2 is pointing to too. So now I have two copies of the same thing in L2. And that's why there's a duplicate list block so that you can have one list and you create a clone of that so that the two clones are no longer related at all. You can change one and not affect the other one. But if you don't use the cloning ability or the cloning block, then the two lists are really the same thing. Now this is also interesting in some other way, because in App Inventor, okay, how many people know what I mean by pass by reference, passing by reference for functions and subroutines? Okay, App Inventor does not have pass by reference, okay? But you can emulate the effect of passing by reference by using a list. Because what a list is pointing to is actually a pointer. So you can actually use that to emulate the effect of passing by reference. Now that is totally an advanced topic, but I just want to point it out because some of you may want to do something like that, and you can do it, you can achieve at least some of that by using lists. Are we doing okay so far with this sample program? Yep.
I have a question about that.
Okay.
So if you have a global variable that's getting used in a function, it's getting modified, right?
Mm-hmm.
But if you pass a function in App Inventor always, if the saves are not going to change when you exit the procedure?
Correct.
It's always a pass by value. Okay.
Yep.
I was having an issue with that. Thank you.
Okay. So what Angela was talking about is, I'll just make a procedure for that purpose here. So if you make a procedure that has quote unquote an input, as a variable, as a parameter, you can in the procedure do something like this. You can say, I want to change that to a constant, let's say x, at 0 here. Okay? And if you call this procedure, would it do a single thing to this x here? That's the question. Okay? So I'll test this by saying, okay, let's go ahead and try to destroy my global variable over here. Okay, so let's go ahead and insert a call from here. So we say, let's call this particular procedure. Let's make the procedure have a name that reflects what it's attempting to do. Okay, nuke. Because it's going to change x. Okay, it's going to change x to a constant of 0. Okay, so the question is this going to destroy my global variable when I pass it over here? Okay, is that okay? Because if parameter x of nuke is really linking to whatever you specify to pass to x, and the set block is changing whatever was used to pass x, then by the time I get to the conditional statement, the global variable L2 is not even a list to begin with. And that should give me some runtime error, because when I try to find out what is the length of a list, and what you're supplying is not a list, it will give me a runtime error. So this will be a good test to see whether when you pass a parameter and you change the parameter itself, does it really affect what you used to pass the parameter with to begin with?
It'll probably just give you nothing at all because you're checking for it being valid.
It should give me a runtime error.
Yeah, because it tries to insert.
It should give me a runtime error because I have to check the length. And the length of a number is not defined. It's not a list. So we'll go ahead and see if this works, if this gives me an error or not. I'm 99% sure that this is not going to affect it, because by default, parameters are only passing by value. So you can change the parameter all day long. It doesn't change what you use to pass that parameter, unless it is a list. If it is a list and you change what is inside the list, that affects the original item. So I will conclude this test today, and then on next week we'll have we'll have the exam 1, which is going to be kind of like a homework assignment. I will give you some code to start with. I would ask you to do something with that code, adding some features, and that's basically the nature of the exam.
Monday or Wednesday?
Do you guys want it on Monday or do you want it on Wednesday?
Wednesday, please.
Huh?
Wednesday.
Wednesday? Does anyone want to do on Monday? Nobody? Wednesday it is. See how easy it is? Doesn't make any difference to me. Alright, so we want to test that one. We can just go actually do it now. I mean, the operator floor cannot accept the argument empty string.
Yep.
Oh, that's separate. That's not it. That's not the issue. I need to check whether it's a number to begin with, because even though I cannot type something that is not a number, I cannot type a single thing and leave it empty. That's the problem. Okay. Make it a 1 then. And it didn't have a problem because I actually did not change the global variable. Alright, so that will conclude our lecture for today. So we are moving on to the lab. If you have any questions with your project or the topics that we talk about in the class, we can go ahead and talk about those things.